Okay. So yesterday we have discussed basically transistors. Okay. Transistor as a switch. Okay. Transistor as a switch. And in that case, we have discussed CMOS transistor as a switch. Okay. This is one of the simple application of transistor, an abstraction of the transistor working. Okay, as a on. If it is on, it is input is one, it is on. The input is zero, it is off. For one kind of transistor, we call it NMOS transistor or NPN transistor, and the type of transistor also there with opposite dual nature. When input is high, it is off. Input is low, it is on. Okay, that is called PMOS or P-type semiconductor MOSFET or PNP transistor. Okay, but here both are abstraction. So I'll consider transistor as a simple switch, whether it is NMOS or PMOS or NPN or PNP. I'm just considering or assuming or considering transistor as a black box. Okay, so the black box is on when the input based on the control signal input is on. This is kind of abstraction. This is especially useful for digital electronics. Okay, which you will learn in the next coming semester. So this abstraction make it much easier for us to understand, appreciate, and generate some interest in the transistor as well as its applications. So yesterday we discussed two types of MOSFET. This is N MOSFET. Okay, and if input is high or one, it is on. Input is zero, it is off. Off means the source. There are some terminals. It has some terminals like drain, source, and gate. And gate terminal is the control terminal. And whatever input going to the gate terminal, if it is high, the NMOS is on. Okay. And if it is zero, NMOS is off. On means the drain or source are short circuited. Off means there is no connection between drain and source. It is like infinite resistance or open circuit. Clear? And its dual is what's the dual of NMOS? It is PMOS, P type MOSFET. It is represented like this with a bubble. Okay, there are different representation of PMOS, but I'm just showing you one. Okay, it also has all these terminals like drain, source, and gate. And but the condition is if my input is if input is given high, if input is given high in the gate on or high or true, what happens? It is off. Is off. Off means drain and source are open circuit, not connected. But if my input is zero or low or no voltage, that means then it is on. That means drain and source are connected and is allowing current from drain source, or is a very low resistance between drain and source, or current can easily flow, whatever. Okay, so this was the case of MOSFET, CMOSFET and PMOS. So if in a circuit, if I use NMOSFET as well as PMOSFET in a complementary way, as a PMOS as a pull-up circuit, NMOS as a pull-down circuit, I'll call it as CMOS design. Okay, what I have told, if in a circuit I have two network, pull-up network and pull-down network. Okay, why it is called pull-up network? Because this network is connecting the circuit to the VDD or plus 5 VDD. So VDD or plus 5 volt supply voltage. Okay, and that circuit is connected to my V output. The mid part of this is so this part of circuit which is connected between VDD and V out, which tries to drive the V output to high voltage, is called pull-up circuit. Okay, so I call this as pull-up circuit, pull-up circuit. Okay, whatever this terminology, just for just making you letting you know these things. I'm just telling, not important for your design. Okay, and there's another pull down network. What is pull down network doing? It tries to pull down the VDD or V out to the ground. Okay, pull down, or it tries to pull down. So, and it is connected to the V out and ground terminal, zero voltage. Okay, so in pull up circuit, in CMOS should be PMOS circuit. PMOS I should be using PMOSs in the pull up circuit, and pull down circuit I use NMOSs. Okay. So we discussed two gates, NAND gate, NOR gate, and CMOS NOT gate also we discussed yesterday. It's very simple. Just apply the conditions. NMOS, if it is high input is given, it is on. Okay. And one specialty you can see here. The input is given to both NMOS and PMOS at the same time. That is the only thing you do. So input will be given like this. Input is given like this. Yeah, this is V input. Okay, all the input A, B, C variables or different signals are given to both the pull down as well as pull up. Okay, because they has complementary option, A pull-up network is on, pull-down is off, something like this. So it is called CMOS, complementary metal oxide semiconductor MOSFET, or CMOS technology. You might have heard CMOS camera, CMOS chip, etc. So these are the latest technology we are using because it has the following advantages. What are the advantages? It has low power dissipation, right? Because VDD and ground is rarely connected together. That is one of the main advantages because this is no direct path between VDD and ground. Is one is on, one is off, one is off, one is on, whatever. So it is highly power saving, right? So we can have battery operated devices like laptops, smartphone, etc. because of this technology. Another advantage of CMOS is high fabrication or manufacturing capacity, fabrication density. You know, uh, unlike in BJT or PNP or NPN transistors, okay, their fabrication point of view that they are a bit difficult or challenging because of a lot of parasitic effect, a lot of current control is required. But CMOS is very easy. That their structure and their device characteristics we'll deal with later. Okay, right now you just understand this is just a black box kind of approach. Okay, now we'll come back to the BJT part also. The same thing we can have the counterpart of BJT. You already know this is two types of transistor. What are they? NPN and PNP. Okay, it will be like this. I'll draw what you already know. For the two types of transistor, we already know. Okay, so what are these terminals? This, just see the current direction. How to understand the terminal? Oh, I know everybody know, but I'm just refreshing. Just see the current direction. Current always flow from P to N, right? Like a P-N junction diode, current always flow from the P to N, right? This is P, this is N, right? You remember that. So the current direction, this is P, junction is P, is flowing to N. Okay, so N, P, so other terminal also will be N. Getting? And in other case, this is arrow is inside. So the P is in outside, right? So inside middle portion junction is N and other portion is P. Okay. So one is NPN, another is PNP. Okay. Just remember the diode convention. Okay. Current flows from P to N. And based on we can get PNP and NPN. Okay. Now, for operating transistor as a switch, whenever we discuss transistor switch, we are in a digital world. Digital world means high and low, 1 and 0, binary. Okay, it makes our life so easy. So in abstraction, and when we assume transistor operating as switch, I'll assume the same operation of NPN and PNP transistor also. That means for NPN transistor, if I say my input is high or high voltage, or high actually should not be voltage, should be current, but whatever. If a high signal is given to the base or control terminal, my NPN transistor is on, right? It is on. That means my collector and emitter are on or short circuited, or it has some resistance, low resistance. Getting? And the other case, opposite case, if I give a low voltage or low current or low signal at the base of my NPN transistor, that means it becomes off. There is no enough signal in the base region. This is the base region. Okay, I think you refresh. This is base, collector, emitter, whatever. This doesn't require here because transistor switch is, we assume transistor as symmetric. That's it. So don't need to worry about the base, collector, and whatever this. So if the base of NPN is given a low signal or low current, it is just an open circuit. There is no connection between collector and emitter, and the switch is off, right? And if it is high signal, high current, it is on. Collector and emitter is shorted. And reverse is the case of PNP transistor. If I give a low signal at the base, then I can say this is on. Okay, the PNP transistor is on. That means collector and emitter is having low resistance, current is flowing, and this short circuit. Right. And if I give a high voltage, if I give a high voltage at the base, so high signal, high current, or whatever signal, I consider this is open. It's not on, it is off. There is no connection between collector and emitter and high resistance or emitter resistance. Okay, so this one should be clear. Now I'll draw some PNP circuit, and you have to tell me what is the application of this circuit. Okay, so